Okay, in this video, we're going to go ahead and do example 3. We have a block sitting on a table at rest. What is the normal force? Okay, so let's go ahead and draw our motion diagram and our free body diagram. In this case, we are at rest. So what we're going to do is we're going to draw our velocity vector and our acceleration vector. Okay, so let's go ahead and draw our free body diagram. So here for problem 3, it says we have a block sitting on a table at rest. So what's physically touching our block? That's right, the table. What's acting at a distance? The Earth. Are we in equilibrium? Yes, because we're at rest. Okay, so we're going to go ahead and draw our forces. And I'm going to draw my support force or my normal force going up and my weight going down. So this is force on block by table, and this is force on block by Earth. Okay, so now we're ready to solve the problem. We're going to use Newton's second law. So we're going to write the sum of the forces equals ma. We're in the y direction again. We're going to substitute in from our free body diagram into the summation part. So this is force on block by table plus force on block by Earth, and that's equal to ma. Now, I want you to notice something. This is your normal force. What does normal mean? Normal means perpendicular to. So this is your support force that's perpendicular to the supporting object. This, again, is your weight. Am I accelerating? No, I'm not. So I'm going to cross this out, set it to E0, and I'm going to write N1 to indicate that I have applied Newton's first law. Okay, so now I'm going to solve for the normal force. I'm going to substitute in magnitude and direction. Again, remember that this plus sign is here because we're adding the forces together. Yes, this is going down, but we're adding it as a vector. We haven't put in the magnitude and direction yet. So let's do that now. So we have force on block by table, j hat, minus capital M G j hat is equal to 0 j hat. Now I'm going to cross out the unit vectors. How can I do that? I'm just dividing both sides by j hat. And notice that they all drop out. Okay, so now I'm going to solve for the normal force, the magnitude of the normal force. I have force on block by table is equal to mg. So in this case, the normal force magnitude is equal to the magnitude of the weight. Now, does it ask me for the magnitude of the normal force or the normal force? It's asking me for the normal force. So I'm going to add the magnitude and direction. Again, this is the problem with most textbooks, most university and college textbooks, is when they ask for the normal force or they ask for the normal force in an example in the textbook, what they do is they just solve for the magnitude. But that's not what they're asking for. They're asking for the force. Forces have direction. If they want the magnitude, they really need to state that in these examples and then the problems. Okay, so we're going to go ahead and give this direction. So we have force on block by table. Which way is the normal force directed? J hat. So that's equal to mg j hat. And I'm going to box my answer. Now, I want to make a clear note about this. The normal force is not always equal to the weight. Okay? A lot of times what happens is students solve this problem, they say, oh, the normal force is the weight, because there's only one force going up and there's only one force going down. But here's the problem with that. When you get into a problem where you're on an inclined plane, the normal force is not equal to the weight anymore. Okay? So you really have to be careful when solving these problems. You really do have to go through all these steps. Now, if you are really intuitively getting this and you've gotten straight A's on everything, I would say, okay, you're probably okay in not doing this. But if you are in any way, shape, or form just a little bit doubtful about your abilities in this material, play it safe. Work this out, write out your steps. Once you stop writing out your steps and solving these problems, you start making mistakes. Okay, I have found this to be the case with all of the classes I have ever taught. When the students follow these steps, they can at least get to these equations. It's when they don't follow these steps that they go wrong. Or if they think they understand it, but they don't really understand it. In other words, they're looking at my solutions and they're saying, oh yeah, I got it, I could do it. But then when they go to solve problems, they're unable to do them themselves. That's when it gets a little bit of a problem. You have to be able to do this part on your own, and you need to be able to answer these two questions, what's physically touching and what's acting at a distance. Okay? Just trust what you have been taught through using the inquiry and by what I'm showing you in doing these examples, and you will do fine. Okay, so that's it for example 3. The next video will cover